Remove the glass funnel from the volumetric flask. Use a dropper to fill the volumetric flask carefully up to the calibration mark with additional distilled water. Read at eye level to check if the meniscus reached the calibration mark. Close the flask with a stopper and mix the solution well by repeated inversion and swirling. Label the volumetric flask with tape.
Now, we will learn how to determine the actual concentration of the sodium hydroxide solution prepared. Since the mass of NaOH we weighed differs from the calculated amount, there will be a slight deviation in the concentration of sodium hydroxide. This means that the concentration now will not be exactly 0.5 molar. To calculate the actual concentration, we need to calculate the actual number of moles of sodium hydroxide we weighed first. We will take the actual mass we weighed divided by the molar mass of sodium hydroxide, which is 40 grams per mole, to get the actual number of moles. Next, we will use the actual number of moles we got to find the actual concentration of NaOH in 50 ml. Hence, we take the number of moles divided by the volume, which is 50 ml, which is also equal to 0.5 liter, and the value we obtain will be the actual concentration.
Before we continue the video, we will now learn how to determine the volume of NaOH solution needed for dilution. To simplify the calculation, we will assume that the actual concentration of NaOH prepared is exactly 0.5 molar. Our task is to conduct dilution to obtain 50 ml 0.25 molar from 0.5 molar NaOH solution. So, what is the volume of 0.5 molar NaOH solution needed for dilution? To determine this, we will use the dilution formula MiVi equals to MFVF, where Mi is the initial concentration, Vi is the initial volume, MF is final concentration, and VF is final volume. In this case, Vi is the volume of the 0.5 molar NaOH solution that is needed for dilution. This is the original NaOH solution you prepared. Hence, to calculate the Vi, we will shift the equation around and substitute the rest of the numbers. Our final concentration, MF, will be equal to 0.25 molar. The final volume, VF, is 50 ml, and the initial concentration, Mi, will be 0.5 molar. After substitution and calculation, you will get the Vi, the initial volume of 0.5 molar NaOH solution that is needed for dilution. As our final volume of NaOH solution is 50 ml, the Vi will be topped up with distilled water in a volumetric flask to obtain 0.25 molar of 50 ml NaOH solution.
Check for breakage and cleanliness of the volumetric pipette. Rinsing with distilled water twice. While rinsing, rotate the volumetric pipette.
Should you rinse the pipette with NaOH or use it as it is? Click on your choice now.